we are going to be doing something a little bit different. So today is John Readey's session, and John is in China, so he pre-recorded the session. So we'll run this pre-recorded video. But Matt Larson is here to answer questions, so you can put your questions in the chat. John covers 2 different topics, so we'll pause midway through, see if anyone has any questions about John's content or anything else. And then wind up with more questions. So I'll go ahead and start the video. Feel free to use the chat. And again, Matt is online to help. Thank you, Matt, for helping, by the way.
No problem at all.
Okay, so let's see my screen share here. Okay, we'll get started.
Okay, hello everyone. Welcome to this pre-recorded session of Call the Doctor. I'm in China right now, and the regular time is a little bit late in China, so Lori is helping me out do this recording. And if there are questions, I can answer them offline, or if Matt or someone is attending, he can probably answer most of these as well. Anyway, today I thought it'd be useful to talk about our upcoming HSDS release. And I did a post in the HSDS Forum today, kind of iterating through what we're thinking about having in the HSDS release. So let's walk through these and see what we have. Okay, so here I've listed all the different features that are in the release. And some of these are already implemented, meaning that they are in the master branch of the HSDS GitHub repo, and you're free to try those out and use them right away if you want. And others are still in development, and others are still in the thoughtware phase. So we'll have a whole gamut. Anyway, the first feature we have is shape reduction. And this is a feature that lets the dataset shape be not only increased, but reduced in size. And this is actually somewhat tricky to implement, because if you think about it, when you increase the size of a dataset, there can only be more chunks to be added. But when you decrease, you have to basically delete chunks that have fallen off the radar, so to speak. And make sure that if you increase the size again, you don't resurface data that was previously written. But anyway, that feature is now implemented. The next one, it was actually related to the work we did for shape reduction, is broadcasting. So in NumPy is the Python package for in-memory arrays, and H5Py implements a lot of NumPy style features in this API. Anyway, in NumPy, there's a feature where you can say have a selection for an array and send a smaller subset of data that gets spread out through the entire selection through some fairly complicated set of rules. So this is now supported in HSDS, meaning that you could say, for example, select the entire data set, write one value in your request, and that one value gets spread out over the entire data set. So that can really help reduce excess bandwidth for a client-server application. The third one is UTF-8 fixed strings. So in the HDF library, it's possible to have UTF-8 fixed size strings. And it's a bit of a non sequitur, because in UTF-8, each character, so to speak, has a variable size. It's 1 to 4 bytes. So it's hard to pin down exactly what you mean by UTF-8 fixed size strings. Usually UTF-32 is used for fixed size strings. In the library, the UTF-8 is just a tag basically put onto the type. And the library doesn't inspect the string to see that it truly is UTF-8. And we follow the same protocol basically in HSDS, right? So you create a fixed size string. You can call it UTF-8. It may be UTF-8, but basically any set of bytes you throw in there will be accepted. Quick scan. So in HSDS, when you do things like list number of objects or the total storage used, that is done asynchronously, meaning that it's updated a few seconds after the last change. Quick scan is a feature that lets you force that recalculation immediately on demand. So whenever you need to immediately know, say, how many objects are in the domain, you can get that information. The n-byte and scale offset filters are filters that are stored in the library. It's not possible to specify those filters in HSDS, but in reality, we don't do anything with those, right? So it won't actually apply these filters to compress the data. It's there for compatibility. On the other hand, bit shuffle filter is implemented, and it works similar to byte shuffle, which is part of the library. But bit shuffle works at the bit level and can be more efficient depending on the type of data you have. For array types, there is enhanced support. I don't think it's entirely working yet, but we support more use cases with array types than we did previously. Moving on, we have field ops. So when you have a compound type data set, previously in HSDS, you had to read all the fields of the compound type anytime you did a reselection. And correspondingly for a write, you had to write all the fields. Now with field ops, you can specify a subset of the fields. So this is very useful, say if you have maybe a compound type with hundreds of fields, it's more efficient to read just the fields you need rather than the whole gamut of fields in the data type. Support for long attribute names, non-UTF-8 encodable attributes. This is implemented. So HSDS is a REST-based service, and as such, every action happens through an HTTP request. There are, to recap, there are 4 basic HTTP request types. There's GET, POST, PUT, and DELETE. The reading an attribute name has hitherto been done using a GET request. And that meant that the attribute name was part of the URL. So what happens now if you have an attribute name that, say, is 10,000 characters long, there'd be a problem because most web server software doesn't support really long URLs. So now you have an alternative way of using POST requests to read attributes. And the way POST works is that you can list the attribute name as part of the request body, which doesn't have a size restriction. In the same way, we're supporting non-UTF-8 encodable attribute names. Not that we're recommending that you use non-UTF-8 encodable attribute strings, but they are supported. Related to that is one, and I'll have a demo of this in a bit, called multi-op attribute. So in the library, you can only read or write one attribute per library call. And that's fine for the library where the latency in doing operations is fairly small. When you have a server, the latency between the client and server can be quite large. So if you have to do, say, create 1,000 attributes, that latency adds up to be a quite significant delay. With the multi-op attribute feature, it lets you read or write multiple attributes in one request. Right? These can be multiple attributes to one group or dataset object. It can be a set of attributes to multiple objects. are going to be multiple attributes and multiple objects. There are various ways to slice and dice that. But it should really be a big performance win for certain use cases. Similar to the attribute changes, we have now support for long link names and multi-op links. These are actually work in progress, but they will be out in master this week, we believe. Hyperchunking. When you're using HSDS to link to an HDF file, there's a common issue where the HDF file was created with, say, a chunk size that was quite small, maybe like 4 or 16 kilobytes. When this is used in a cloud storage context, those small chunk sizes really slow down the request processing. So we've implemented what's called hyperchunking. In hyperchunking, we create a virtual chunk on the HSDS side that maps to multiple HDF5 chunks in the HDF5 file. And the software in HSDS lets you efficiently read the smaller HDF5 chunks, but it's giving the appearance to the client that they're actually larger chunks. It's been implemented for a while for 1D data sets, but we are planning to support also multiple data sets for hyperchunking. Okay, moving on. H5 copy, H5 move are library operations that involve either copying or moving either single objects or a whole branch of the HDF5 tree. It's an interesting problem from the point of view of a client server because hitherto, all the operations supported by HSDS were things that can be done in a fairly reasonable amount of time. And by reasonable, I mean no more than 30 seconds or so. When you have an operation that could potentially take much longer, and with H5 copy, you don't know how many megabytes or gigabytes or terabytes of data might be involved, you can't really pin down how long the operation would take. So thinking about this and thinking of ways that we could support H5 copy, in addition, other long-running tasks, there's a design spec called async task. And async task is basically a design pattern that lets you submit tasks to a server that may take quite a while. And rather than just having your request go out, what happens is you get a token back. And then the client would use that token to check on the status of their task. So they would periodically check, and when the task is done, they'll get a response back saying their task is done, and then they can proceed to do whatever they're doing. So this would enable us for H5 copy. And in addition, I think there is quite a large set of other possible operations that would be quite interesting to support server side rather than a client. For example, suppose you have a large 2D data set and you want to compute, say, the mean per row of the data set. Currently, you'd have to copy the entire data set to the client, calculate the mean, and write those results back to the server. If we had, say, a mean calculation engine built into the server, then you could tell the server, hey, server, I would like to compute the mean for this data set. And the data set would do that computation and let you know through this design pattern when it's done. This enables you to avoid a lot of data movement and should be quite a bit more efficient, especially when the client is remote from the server. So in addition, I think beyond just a fixed set of operations, it will be possible to support a plugin mechanism where individuals can design their own set of operations for whatever type of code they're doing and build those into the server. So I think this is an interesting idea, and I would be very curious if anyone can take time to read the design doc and has feedback or ideas to take this forward, please let me know. Finally, in HSDS, we support variable length variable length types as chunks. In the library, data sets with variable length types aren't compressible because the actual values aren't stored as part of the data set per se, they're stored in the heap. In HSDS, we have a mechanism where we store all the data for a chunk for a variable length type as one blob, and we can compress that and retrieve it. And that works fairly well. The only issue is performance, because the encoding we do to take a chunk of variable length type and serialize that is implemented in Python, and it's not very efficient. So the idea here would be to use the Parquet file format, which does very well with variable length types, and use that to encode the chunks. Okay, and that is not yet started. So those are the changes. And in addition to the code changes, we would like to have documentation updated for the REST API. So I put a link here to the last known version of the REST API docs, which is quite ancient. The REST API is still pretty much valid, but even before this release, there have been quite a few new query parameters and such that have been added to the API that would be good to document. Okay, and I think that is that. So again, any feedback you have on any of these features or some other feature that you'd like to see, please let us know. Now I'd like to switch over and do a little demo of that attribute multi-op feature. So let me switch my screen share a second.
Okay, so I'm pausing John here for a second. Matt may be able to answer some questions, or if there's any discussion points we need to have. Does anyone have anything right now?
Lori, I just had one question. I don't know if you want to get into it here, but I didn't know if John had thought about, there was it was a couple of years ago, where we had presentations on UDFs, which were user-defined functions that were embedded in HDF, and they were activated when the data was read. And this was a little bit of a hot topic, and it was a very interesting concept. And I wondered, when John was talking about shuttling Python code over to the server side for HSDS, I wondered if he had gone back and taken a look at UDFs and to find out if there was any chance of implementing UDFs over in HSDS, which it seems, at least on the surface to me, does a bit of a similar thing, or could be made to do the same thing. So that's just the marker I want to put in at this point.
Okay. Anyone else have anything to say? I'll make sure to let John know that he.
Do you want me to put something in the chat?
Well, I mean, we're recording it, so I'll
okay.
Yeah, I'll tell John.
Okay.
And make sure that he watches it. I hope he will anyway. But yeah, I'll make sure he watches this and gets your question.
Yes, if he says it has some relevancy, or he just hasn't thought of it. But I know when Lucas presented it, it was really quite intriguing, I think. So
okay,
thank you.
Thanks, Robert. Okay, I'll resume the video then.
So I wrote a little script here to illustrate this. So I have two Python codes using the REST API. Okay, so these features aren't yet built into H5PD, so I have to resort to illustrating these using REST API, but eventually H5PD and the REST file hopefully will have support for doing these operations in a more familiar API context. Anyway, so the first one is called make attribute serial. And what it does, it takes a domain path, a number, account for a number of groups and number of attributes. And it creates that many groups. And for each group, it creates this attribute count number of attributes. And it does it the old-fashioned way where it just, let's see here. It, for each group, it creates a group. And then within each group, it creates this attribute count number of attributes. Okay, so the number of HTTP requests is simply the number of groups times the number of attributes, basically, right? So one HTTP request, one put operation creates one attribute. Now, if we contrast this to the multi version of this, which uses this new feature, the same parameters to the code, and we come in here, we are still creating groups in the serial way, but now for attributes, we do a put that takes a list of object IDs and a list of attributes. And for each of these IDs creates that set of attributes. So I was saying there's other ways to do this, right? You can create a bunch of attributes for one object. You can create different attributes for different objects. But this is maybe a nice pattern where you basically copy the same attributes to multiple objects. And so what we have here is one put that creates all the attributes. Okay, so let me show you how this works. If I do Python make attribute single, well, attributes TRSERIL. Public XML Python. Okay. So it says make attribute serial.py, group count, attribute count, and domain. Let me check this 1 second. Yeah. So let's say we want a time thing here, see how long it takes. And we'll create 10 groups, and each group will create 1,000 attributes. And the main will be home test user one ATRSER.ATI. So it created group one, it created 1,000 attributes, group one, now it's iterating through group 2 and 3. So as you can see, this is not really speedy. And the reason it's not speedy is that we basically had to create 10,000 HTTP requests to create the 10,000 attributes. So it took 30 seconds. Now let's try the multi version of this. So I'll change this to multi. And I'll change that. Multi. Okay. So it creates the groups, and it basically most of the time was spent creating groups. And once the groups are created, the creating the 10,000 attributes just took a second. So it went from 30 seconds to less than 3 seconds with this feature. So it just goes to show that for client server applications, you really have to try to do more, right, with each request, because in comparison to the library, going from the client to server always involves a bit of latency that you can't really get away from. But here what we're trying to do is enable you to do more with less, have fewer operations that do more work. And that's kind of the theme, I think, for this release. Okay, so that's about all we have for this call to doctor. Again, if there's any questions on what I've just presented, you can respond to the forum or let Lori know through a chat, or maybe someone there will have some ideas that they can respond. All right, thanks very much. Good night.
Okay, so that's John's recording. Anyone else have anything to talk about, contribute, questions? Nope. Okay. Well, I will make this a recording overall and post it and make sure to let John know that Robert had some things to talk about. So I appreciate it. Thank you, everyone. We'll see you next week.